Hi Tim, and welcome back to Getting Into Scanning. This video is going to cover cloud-based registration in more detail, and will follow on for the last video covering registration in general. Cloud-based registration is the most widely used registration form in the market, and while it is quick and efficient, there are several things to consider when embarking on a project with cloud-based scanner. When looking at cloud-based registration process, it is looking at two scans, identifying common areas, and trying to join them together as best it can using algorithms. This means that there can be a little bit of play, for a better term, on how close it gets. It's also why it can be significantly impacted by the type of project and the data within a project. At its core, cloud-based registration relies heavily on common vertical surfaces in the scan data. It is not looking at the corners of these flat surfaces, it's looking at the center of the flat area and then relating that to what's around it to position itself. When we're talking about errors here, we can be talking as little as a couple of millimeters through to meters in extreme cases. This is why it's worth keeping an eye on the registration visually, as well as the reports coming out to make sure the registration has worked. Looking at these three examples here, cloud-based registration will struggle most to achieve high accurate results in option A. There is nothing to register against. This would most commonly be seen in outdoor projects on a country road, for example. In projects like this, the automatic registration process may fall over with mismatching or not even being able to produce a result at all. For this reason, there are generally those manual tools which we've discussed earlier to help identify common areas in scans to prompt the system to then register against that can and help produce results. It must be noted though that trees, light poles, in this case, are not seen as large flat surfaces. While they are easily identifiable, they are generally round objects scanned from different angles. So while they can assist in the registration process and tying scans together, they are not optimal locations. Option B is better with large flat face on one wall. However, it can still be mismatched in the other axis and can introduce a little bit of drift. This generally produces a closer result, as it's usually there is a bit of variation in that flat surface and it can get the depth that it needs to lock it into place. But it is a consideration here as to why errors may still creep into projects like this. Finally, for indoors with solid surfaces, scan registration will work well within the cloud-based registration process as the scans are locked into place in each axis. So you might say, why is this an important consideration? I've been out doing my scanning and my report says that I have generally 1 millimeter between each scan. Well, when looking at scanning, we generally do multiple scans back to back in a single registration set. When we do this, the error propagates, and not in a constant direction either, I might add. So a project done over 1 kilometer in a straight line with 40 scans to account for overlap will see at best 40 millimeters of error creep into the project by the time it gets to the end, if every scan has 1 millimeter of error. This is a best case. Usually this will be significantly higher as projects outside can be at best 2 to 3 millimeters in registration errors, which is still pretty good, I might add. But again, this propagates through the direction, driving the number up by the time you get to the end. And this is not going to be in a constant direction, as each scan will be different and the direction the error is occurring is going to be different. How can we overcome this then? Well, there are a couple of things. First off, we want to minimize where the error is coming from. So if you're using unleveled scans, every 8th scan or thereabouts should be leveled to make sure that it's on track. Wherever possible though, all scans should be leveled so the data isn't introducing errors in another direction. Shorter registration sets too might help, or tying to control regularly throughout a project and have registration sets between control can help as well. At the very least, this will tell you how far you are out in each section, and you may need areas to investigate further. Having other instruments on site too to tie down certain locations like station-based scanners is an advantage. The example would be if you're doing a road network, you could use station-based scanning and intersections and use cloud-based scanning in between and tie the cloud-based scanners to the point cloud produced at the stations to lock it into place. There are all sorts of different techniques which we'll try to cover in the following videos though. Overall though, this video is to highlight what is going on with cloud-based registration to help make an informed decision. It produces a very good set of results as a registration process and is used extensively in outdoor scanning projects and over long distance. This video is just to highlight how best to chase high accuracies and work in open areas without vertical surfaces, as this is an important consideration when using this type of registration. As always, thanks for watching, and please feel free to reach out if you have any questions or want to discuss this further. Happy scanning!